Okay, girls, so what I'm looking at here now is 2012 Part B, which is a question on the handout we were working on in class. So it says that you have a particle projected down an inclined plane with an initial velocity of 20. So it's going down the plane this time. So if I see down the plane, I'm just going to write that over here in big red letters to remind me of something when I'm setting up the table. Right, so off it goes at 20 metres per second. And it says the line of projection makes an angle of 90 degrees with the inclined plane. So this is sent off at a right angle. The plane is inclined at an alpha to the horizontal. The plane of projection is vertical, blah, blah, blah. The particle strikes the plane at Q. Okay, so it comes down here. The range of the particle on the inclined plane is 1600 root 3 over g. Okay, so the SI is 1600 root 3 over g. And of course the range happens when the Sj equals 0. So I have the SI when the Sj is equal to 0. I've got to find the value of alpha first of all. Okay, so first things first, we'll set up a table. So I have my I and j components. Now, the initial velocity. Okay, it's just going in a j direction because it's at right angles, but I'm going to fill in the value anyway. So I know that if this is sent off at a speed of 20, then this is 0i plus 20j, but I'm going to go through this here. So it's going to be u cos of the angle, which is 90, that's the projection angle, and u sine of 90, the projection angle. U, of course, is 20. So this becomes 20 by cos 90 is 0, so that will just give me 0. And sine of 90 is 1, so u times, or 20 times 1 will just be 20. Now my acceleration due to gravity is going to act straight down towards the centre of the Earth. I'm going to break it into its two components here. I'm going to squiggle that fella out. And I'm going to label my two parts. So this bit here, remember, will be G. So this is my G here. Remember, if I do a similar triangle, draw a similar triangle around that G, perpendicular to the plane, parallel to the plane. This blue line up here is the parallel one. And then if I compare angles, remember, we did this in class, this angle here will be alpha, that one up there. So this one, parallel to the plane, will be G sine alpha, because it corresponds to the opposite side of this triangle that I would have drawn. And of course this one here is G cos alpha. I'll just put that in blue. Okay, so now I have my G resolved into its two components. That diagram is very small. I would prefer a bigger diagram. Okay, so in the I direction, because it's coming down the plane, of course, it's minus G sine alpha. And of course, this is minus G cos alpha because it's going down the j-axis. T is arbitrary. So the V becomes U plus AT, 0 minus G sine alpha t. And this one, of course, is 20 minus G cos alpha t. Because it's down the plane, I change that minus to a positive. So the I components will become positive. The S is going to be ut, which of course is 0t, minus a half G sine alpha t squared. And this becomes ut minus a half G cos alpha t squared. Again, because it's coming down the plane, I must remember to change this to a half. So just make sure that when you have these down the plane ones, that you say that, make some sort of mark on the page to remind you to turn those to positive. Right, so I know that the Sj is 0, and I know that what the Si is. So if I compare or match them off, the Si is equal to 0. T, of course, is 0. So Si is a half G sine alpha t squared. And the SI is 1600 root 3 over G. That's equal to a half G sine alpha t squared. And the other thing I know is that the Sj is 0, and my Sj is 20t minus a half cos alpha t squared. That's equal to 0. Okay, so you have a look and you see which one is going to be the easiest one to use for a t. I'm going to select this one. So 20t is equal to a half cos alpha t squared. So if I divide all the way, I've dropped a g there, a half g. If I divide all the way across by t and multiply that by 2, this will become 40 over g cos alpha is equal to t. So I'm dividing this by t and that by t. That'll give me t to the power of 1. And then I'm cross multiplying by the g over 2, and the cos alpha comes down under the line as usual. Okay, so this, I'm going to use this for my t. Now I'm going to substitute obviously this t into that expression, and then that will give me lead me towards sine alpha. So I'm going to say 1600 root 3 over g is equal to a half g by the sine of alpha. Now t squared, I'm going to square this. So this is going to become top line squared 1600 over g squared cos squared alpha. Okay, and I know that that is equal to, so now I'm just going to work through this and try to find alpha. So this will become 1600 root 3 over g is equal to, that g will cancel with that square, so this will just become now, and that 2 will go into that, I'm going to leave that 2 for a minute actually, so that's going to just give me sine alpha by 1600 on the top line over, this will become, I've still got the 2 here, and over g and a cos squared alpha. So things will start to cancel off. That 1600 will cancel with that 1600, that g will cancel with that g. So on the right hand side I will just have root 3, on the left hand side I'll just have root 3, and on the right hand side I'll have sine alpha over twice cos squared alpha. So I'll cross multiply here and I'll get twice root 3 cos squared alpha equals sine alpha. Now you have to decide, you're trying to find alpha, so now you have to try to decide what's your best option here. You know, what's the best thing to do to find and get alpha? We could divide both sides by sine. That would become 1, of course, but then I'd be left with a cos and a tan over here, so that wouldn't really be much use to me. So have a look at your options, go to your log tables, look at all the different options you have, and one of the ones that you do have is that the cos of cos squared alpha is equal to 1 minus sine squared alpha. So I'm going to use that one, because what that will do now is it will give me a nice quadratic in terms of sine. So this side will become twice root 3 into 1 minus sine squared alpha equals the sine of alpha. So that's twice root 3 minus twice root 3 sine squared alpha equals sine alpha. Now I have a quadratic in terms of sine, so what I'll do is bring everything over to one side here, and I will get I'll bring everything over to the right, twice root 3 sine squared alpha plus sine alpha minus twice root 3 is equal to 0. So I'm going to solve for sine alpha. So I'm going to use ABC formula to solve for sine alpha. So I'm going to say minus b. Now of course a is twice root 3, b is 1, and c is minus twice root 3. So what is sine alpha? Sine alpha is equal to minus b plus or minus the square root of b squared minus 4 by a by c all over 2a. And when I work all of that out, this works out really nicely into minus 1. So sine alpha is equal to minus 1 plus or minus the square root of 49 all over 4 root 3. So of course that's 7. So this will give me minus 1 plus 7 over 4 root 3, or minus 1 minus 7 over 4 root 3. I'll opt for the positive value of sign, because that's going to be in my first quadrant. Minus, of course, would take me into the second quadrant. If I wanted 2 values, I could do that, but I only want 1 value. So my sine alpha here is going to be equal to 6 over 4 root 3, which of course is 3 over twice root 3. If you put that into your calculator, that's an alpha of 60 degrees. Okay, so we have the first part, find the value of alpha. Now it's the next part that we would be unfamiliar with, so that's the one that we're after here. You've got to find, the second part says, find the magnitude of the rebound velocity. Okay, magnitude, remember we're going to use the modulus, so the magnitude of the rebound velocity. Okay, so let's see what's happening. So we have this inclined plane, we send off a particle, it hits the plane at Q and it bounces. So we have an incoming velocity and a rebound velocity. Now the incoming velocity is the VI plus Vj on landing, and the landing is when Sj is equal to 0. So we already know what happens when Sj equals 0. We have that from the first part. So the Sj equals 0 gives me a time. So T is equal to 40 over g cos alpha. So T is equal to 40 over g cos alpha. That is when the particle hits the plane. I know the alpha is 60, so this is 40 over g cos 60. And of course the cos of 60 is a half. So that just gives me 80 over g. So that's the time of landing, the time when it bounces here, or when it hits the plane. Okay, so that's the first thing. Now the other thing, have a look at this. I'm going to turn the plane around, make it an y-axis. Okay, so in comes the projectile, hits the plane and bounces. And of course, when you hit a fixed plane, you can get your rebound velocity by taking the coefficient of restitution into consideration. Tells you in the question that you've got to find the magnitude of the rebound velocity if the coefficient of restitution is a half. Okay, so E is equal to a half. So I need the VI plus Vj, the incoming velocity, and then I'll get the rebound. Okay, so my incoming VI, I'm going to get from my table over here. My incoming VI is g sine alpha t. And when I put in my value of t, sine of alpha is sine of 60. My t is 80 over g. The g's will cancel. Sine 60 is root 3 over 2. So when I work that out, that incoming velocity for the VI will be 40 root 3. Those g's, of course, will cancel. Now let's get the Vj. The Vj, I'm going to get from the table I've already done, which is 20 minus g cos alpha t. So 20 minus g cos alpha t. Of course, the alpha is 60, and I know the t is 80 over g. So this becomes 20 minus g cos 60, which is a half, by 80 over g. Those g's will cancel. That's a half, that's 40. So 20 minus 40 is going to be equal to minus 20. Okay, so my I component for the velocity is 40 root 3 and the j component is 20. So my incoming velocity, 40 root 3i minus 20j. So that's the velocity with which it strikes the plane, and then it rebounds. So I'm going to say that's an I-axis strike, which means the I component stays the same. So this my rebound velocity then will be 40 root 3i. That won't change. Now this will change. I'll change the sign to a plus. I'll multiply it by e, and that will give me my new j component. So this will be 40 root 3i. E, of course, is a half, so that's going to be plus 10j. So I'm nearly there. I have the rebound velocity. The magnitude of the rebound velocity then to finish is the modulus of this. So it's the square root of 40 root 3, all to be squared, plus 10 to be squared. So this will give me 40 at 1600 by 4800 plus 100. Square root of all of that, of course, is 4900. And that gives me 70 meters per second for the magnitude of the rebound velocity.